How's it going, everybody? I wanted to go over graphing proportional relationships. So we're going to start with this scenario, this example, and the word problems in the scenarios are pretty important because we'll graph a line, but sometimes we need to look at a line that doesn't have a word problem or a scenario, and maybe think about what the line is representing, and what kind of a scenario, what kind of a word problem it could be representing. So here we go. Let's start it off here with our situation coming across. It says, congrats, you've just taken a job at FedEx. Your job is with package design, and you need to decide how to stack items for shipping. Your first task is to stack boxes that are each 13 inches high. And you can see I've circled the 13 right over there. That's going to be important. Each box is 13 inches high. Complete the table and graph the line that models the height of the stack as you add each box. Okay, so we're stacking boxes, each one 13 inches. We're basically filling out the table by 13, and then I think we're going to go on and graph it. So let's knock out this table real quick. So we have 0 boxes. We have 0 as far as our height. So throw in a 0 there. We got nothing. If we put 1 box, well, 1 box is 13 inches, so we should start off with 1 box at 13. And that might be our unit rate right there, but we'll come back to that. 2 boxes, well, 2 times 13, 26, and you probably get the idea here. We're going up by 13s here. So 3 times 13, 3 and 39 get us, 3 and 13, I'm sorry, gets us 39. 4 is next. 4 and 13 gets you to 52. 5 and 13 should take us to 65. We should get a 5 on the end of that. A little messy, I could fix that. And then finally, if we go 6 boxes high, pretty high, we're going to 78 inches right there. 78 inches. It's about 6.5 feet tall or whatever, but we're in inches. Alright, we fill out our table. Check. Awesome. Way to go. Way to go, us. Now we can graph this thing, okay? And to be honest, this is probably a bit of a review, but we're looking at how we're going to use this story and kind of graph the proportional relationships leading into slope and the unit rate. So let's graph this real quick. So we've got our numbers in the table. I'm going to zoom in here so we have some more space. All right, and let's start graphing this. First spot, I'll use the red dot. We're going to be at 0, 0. So obviously we'll have a spot there. We got nothing. 1 box gets us to 13. So we'll go 1x and then up to 13. About-ish right there. That'll work. Next up, 2 boxes gets us to 26. So that should be about right. A little over halfway. I did a pretty decent job. All right. 3 boxes gets us to 39. Just under 40. Just under 40. Throw a dot in there. 4 boxes gets us to 52. Just over 50. Throw a dot in there. Pretty good. We're at 65 on 5 boxes. Right in the middle of 60 and 70 is going to be 65. And then finally, 6 boxes gets us to 78. And messy dot, but we get the picture. Obviously, if we graph this proportional relationship, we're going to end up getting a straight line. Should be getting a straight line all the way through, going up that way, and that's our positive proportional relationship. So below that, I know you've got some questions here. Looks like this. Unit rate. What is the slope of the line? How does the unit rate compare to the slope of the line? All right, well, we talked about the unit rate going back a little bit. Unit rate for one box, switching over to green here, was about 13 inches high. So that's our unit. Remember, unit, we're talking about 1 for one thing. So we're talking about unit rate. Unit rate should be 13. And if we want to write that in equation form, in either the y equals kx or what we're going to call the y equals mx, then we could go forward and we can say that the equation is y equals 13x. Same thing, right? Okay, so then slope. We're talking about the slope. When we're talking about the slope, I'm going to back up a little bit. How much is this line going up by each time? Slope, how is the line going up, going down? Well, this line is going up, a positive slope. How much is it going up by each time? Well, if we look at our table right over here, in our table as we went down, it was going up by 13. Okay, so basically, our unit rate, our slope is going to be 13 as well because we're going up. So you got a unit rate of 13. We have a slope of 13. The last part says, how does the unit rate compare to the slope of the line? Well, you're probably putting this together right now. Unit rate and slope are the same. So actually, when we're looking at that, slope of a line on a graph, if you didn't have a table, if you didn't have an equation, The slope is really showing you the unit rate as it goes up or goes down. The value that it's going up by is the slope and the unit rate. So we want to make that connection here as we go through these notes, all right? So let's try one more example real quick. We'll fill it out real fast. This one will go a little faster. Again, we have a scenario or a word problem. Those are still important because, like I said, sometimes we'll start with a graph with no other info, and we might need to tell a story, write a word problem, be able to maybe define what's happening in that line in the slope. And so understanding the word problems, how they work with the graphs, is important. So let's check out this one right here. In a recipe, the number of muffins is directly proportional with the amount of flour you use. A recipe for 2 dozen corn muffins calls for 3 cups of flour. Complete the table and graph the line that models this situation. Cool. All right. Let's go in green. So our information here, 2 dozen corn muffins calls for 3 cups of flour. 2 dozen. Well, 1 dozen is 12. 2 dozen I know is 24. So if we're at 2 dozen, let's fill that in first. 2 dozen is 3 cups of flour. So we can throw a 3 in there. I think that the pen will let me write. Gotcha. 2 dozen is 24. So then maybe we could figure out like a unit rate for 1 dozen. 1 dozen is 12. So that would be 12 is half of 24. So for 1 dozen, or 12 donuts, we should say 12 muffins, we should have 1.5. Half of 3 is 1.5. So let's put that in there. So I bet we have a pattern where we're going up by 1.5 just based on what I see. So, and that's true. We're basically going up by 1.5. Because if we double 24 right over here, we would get 48, and that would take us to 6, doubling that number, and so on and so forth as we move up. So we're basically going up by 1.5 each time. So from 36 muffins is going to use 4.5 cups of flour. We already have our 6 in there, so 60 muffins is going to go in and give us 7.5. We continue to go up by 1.5 cups here. And then 72, well, we're doubling the 36. We're doubling the 36 from here on 72, so we double the 4.5. That's going to be 9 or 9.0. Make sure there's some point zeros in here actually to make this kind of all match up, be consistent. And then 84 would get us to another cup and a half, and we'll get to 10.5. So we filled out our table with our dozens right over there. And now we want to go and we want to graph this thing, okay? All right, let's graph it up. I will got our values in there. I'm going to zoom it in a little bit. This is a little trickier because we got to write in the numbers, okay? So we can do that. I'm going to try to do it real fast. It might be slightly messy, but we'll get the gist. We'll get it. So X is going in dozens, and 12 basically as we want to do this. So what we're probably going to do is go in and number this thing off and say, hey, look, we can do this by going up to x84. We're going to do this by dozens, essentially. So 12 would be 1 dozen. 24 is our 2 dozen. 3 dozen right over here is 36. 4 dozen is our 48. Let me make that less messy. 5 dozen is 60. So I'm going to put my 5 there. 6 dozen gets you to the 72, and then 7 dozen would be 84. And I'll write that in right there. If I can barely scratch it in, we're going to put dozen, D-O-Z-E-N. So we know that the number represents a dozen, okay? All right, going up on the left side on our Y, wow, that's pretty basic. We could do single digits going up there because we're basically just going from 1.5 to 10.5. Pretty basic. So we can do that. We can go up just by ones. How about I do that in blue? We'll go with 1, 3, 4. Yeah, we're going to have to go like this. 2, 3. I think we can fit it in. 4, 5, 6, 7, 8, 9, and of course 10. Not too bad. Not too bad. Not too messy. Got it in there. Okay, let's graph it. We're going to red and we graph these. So let's start with 12 and 1.5. That's 1 dozen, by the way. So 12 is 1 dozen, and that's at 1.5. So right in between 1 and 2. 2 dozen is at 3. 2 dozen is right on the 3. Perfect, right over there. 3 dozen is 36, and that's at 4.5. 3 is at right in between 4 and 5. So we should be getting the proportional relationship as we go up. Sorry, I had a bad dot in there, so let me go put that. Looks pretty good so far. And then 4 dozens is 6. So 4, I'm going up to 6. Messily. There we go. 5, I'm going to 7.5. Perfect. 6, I'm going to 9.0. And I know the last one's at 10.5. So I'm going to just come up and throw that dot there. And we've got basically our proportional relationship. If we want to connect these up, we'll get a line that goes all the way through. And it's looking pretty good all the way through there. So proportional relationship graphed right over here for we're using basically every dozen is 1.5 cups of flour. So if we wanted to show the unit rate or the slope, what are we going up by each time? What are we going up by? We're going up by 1.5. So we could basically say that the y equals 1.5x, and that can be our slope, that can be our unit rate as we go up. So that's the big takeaway from here. We'll close this out, is to remember that the unit rate and the slope represent the same thing as we graph up. And great job following along here.